Okay, I'm going to go over this, and then I'm going to talk about what you need to make sure you look over for the test tomorrow. And then anything that's not on tomorrow's part of the test will definitely be on Wednesday's part of the test. So I'm just going to kind of go through these with you, and it says find the radian measure that corresponds to each degree measure. And so for 330 degrees, I don't even have to do that because I know that's from the unit circle, and that's 11 pi 6, right? 405 though, if I was going to convert degrees to radians, I'm going to multiply by pi over 180, and then I'm going to simplify that. So if I divide by 5 there, that would be 81 over 36 pi, but then I can divide by 9, so that would be 9 pi over 4. Is that true? So 45, it's divisible by both of those? Yeah. And so simplify, right? But that's an exact answer. Negative 150 degrees, if it's negative, then I'm going to convert it to the negative radian. And again, you could do pi over 180, or I know 150 is what? 5 pi 6, so that's going to be, I'm not going to do it. It's going to be negative 5 pi 6, because 6 pi 6 would be negative 180. 240, isn't that one also from the unit circle? 240 is pi thirds, so 4 pi thirds. But you could do all of these by the conversions, right? I just know those. 36 degrees, pi over 180. So divide by 36. I think that's just pi fifths, right? 36 over 180 is pi fifths. Those are exact answers. So converting from radians to degrees or degrees to radians, that's something you need to know how to do for tomorrow. I'll even tell you, I think this is on the calculator portion, but you have to give me an exact answer. So you don't have to know how to simplify all this, but leave it in terms of pi. Okay? Goodness, there's a lot of these. All right. I should have done these ahead of time. Number 2, find the degree measure. So if I'm going the other way, so if I'm doing 9 pi halves, 2 degrees, I'm going to multiply by 180 over pi because I need degrees on top. So 2 goes into 180, 90 times. So that's 810. Degrees. Make sure you put your degree symbol. Negative 2 pi thirds. Again, I'm just going to do what I know. 2 pi thirds is 120, so this is just negative 120 degrees. 7 pi fourths, I don't need to do the conversion on that one either, because it's just, what, 270 plus 45, which is 315 degrees. 5 pi, well, that one I'm just going to take times 180 because I don't know what 5 times 180 is 900 degrees. And pi fifths, hey, we just did that one. I think it's 36 degrees, but I'll show you. If you take 180 over 5, you get 36 degrees. Okay? Number 3, also really good things that you need to know for the test tomorrow. So I'm going to circle all the stuff that you need to make sure you can do on the test tomorrow. Number 3 is also on the calculator part of the test that you're going to take tomorrow, but it's formulas, okay? So it says essential angle theta is subtended by an arc 20 centimeters long on a circle of a radius 2 meters. Find the radian measure of theta. Well, this is arc length, right? S equals R times theta. So S is the arc length, which is 20. The radius is 2. Oh, wait, this is in centimeters and meters. I probably should make that the same, right? Is there 100 meters? I mean, 100 centimeters in a meter, Parker, is that true?
Yeah, I think it's 100 or 1,000, I can't remember.
I think it's 100. I don't know either. I think it's 100. So I'm going to say there are 200 centimeters. That's important. So S equals R times theta. If I did my conversion right, the arc is 20, and the radius is 200 centimeters. So if I'm going to solve for theta, that would be theta equals 1/10. If they gave me an angle, then we would use that, right? So it says find the area of the sector determined by theta. So area is 1/2 pi r squared theta, and the radius. Well, now are we going to use 2 meters or are we going to use centimeters? I don't know. I guess it just depends on how you label your answer, right? Since I changed the centimeters, I guess I'll just keep it as centimeters. Should be the same answer if you label it as meters, just a different number, right? Because labels matter. So I'm going to use 200 centimeters, okay? And then my theta as 1/10. And so then 200 squared divided by 10 divided by 2 gives me 2,000 pi centimeters squared. If you did that as meters, you would take 2 squared divided by 10 divided by 2, which would be 0.2 meters squared. And I think that those are equivalent in terms of square meters. We can have a metric talk when I get back. I can tell you the ones on the test don't make you convert centimeters and meters, all right? So maybe number 4 would be better to look at for what you're going to see on your test, all right? Actually, I'm going to say that. I'm going to erase number 3. Number 4, this is what I know is on your test. They give you an angle, like what was on our quiz number 1, and it says find the length of the arc that subtends an angle of 70 degrees on a circle of a diameter of 15 centimeters. So first of all, if the diameter is 15 centimeters, then I know the radius is half of that, which is 15 over 2, or 7.5. If they give me the angle in degrees, I have to change that to radians, right? And I want an exact answer. And so I'm going to cross out the zeros there. I don't think anything else simplifies. So 15 times 7 gives me 105 pi over 2 times 18, which is 36. And that's going to be my answer. That's going to be my length in centimeters. And part B says find the area of the sector. And area is 1/2 pi r squared theta. So the radius is still 15 halves, and theta is still 7 pi over 18. And make sure you square that first, right? So I'm going to rewrite it up here so you can see. So 15 squared is 225 over 4 times 7 pi over 18. And now I just want to simplify. And if you want to just multiply the cross and multiply the bottom and then simplify, you can. Gosh, I don't think anything simplifies on this one, actually. So 225 times 7 is 15. Do I get pi squared in this? 15 pi squared? Not 15. Because I have 1/2 pi r squared theta, and theta is also in radians. (1575) pi squared over 2 times 4 times 18, which is 144. Am I right on that? I don't know why I have the double pi. I don't remember having that before. 1/2 r squared theta? Is there not a pi in it? I swear this is my formula. Okay, sorry. I'm just going on. I think that's right. You check me. Okay. Number 23. Find the quadrant. So this is just knowing that secant is the same as cosine. And so cosine is negative and sine is positive. So that's like saying the x is negative and the y is positive. So that would be quadrant 2. Cotangent is y over x. So if cotangent is positive, I know it's in quadrant 1 or quadrant 3 because that's the only place the x and y have the same signs. Cosecant goes with y. So which one of those has a y that's negative? That's quadrant 3. Cosine is x. So if x is positive, I know I'm either here or here. And if tangent is negative, that has to be down here in quadrant 4. So that's just kind of keeping all your signs straight. Gosh, I'm really stressed about that area of a sector. I don't know what I'm doing wrong. All right, number 24, find the exact values of the remaining trig functions if sine is negative 4/5 and cosine is 3/5. And so this one, they're giving you the triangle basically, right? But if sine is negative and cosine is positive, that means we're down here in quadrant 4 because sine is negative 4/5 and cosine is 3/5. So now you can just do the rest, right? So tangent would be y over x, so that would be negative 4/3. Cosecant is the reciprocal of sine, so that would be negative 5/4. Secant is the reciprocal of cosine, so that's 5/3. And cotangent would be negative 3/4. We would do the same thing for part B here. Find the exact values. And so this one, they give us cosecant and they give us cotangent. And so cosecant, remember, is like what? R over y, and cotangent is x over y. And again, think about what quadrant you're in. If cosecant is positive, I think that's a positive, or is that a negative sign? It looks positive to me. It's connected there, and this one's negative. So if cosecant's positive but cotangent's negative, that would be up here. So y is 2, this is 13, which makes x negative 3. They give us everything, and now it's just writing the rest of them out. So sine would be 2 over the square root of 13. Cosine would be negative 3 over the square root of 13. Tangent would be negative 2 over 3. And what am I missing? Secant would be negative square root of 13 over 3. So make sure you figure out what quadrant. Calculator part. The big thing on the no calculator part is knowing your unit circle. Okay, so it says without the use of a calculator, find the exact values of the trigonometric functions corresponding to each one. Goodness gracious, how did I really give you this many to do? Okay. So I don't want to do all of these, but 9 pi halves. You can keep subtracting 3 pi, or you can think about, like, what is 9 halves? 9 halves is 4.5. So 4 pi would always be here. So a half pi would be up here at 1, 0. So the sine of 9 pi halves would be 1. The cosine of 9 pi halves would be 0. The tangent of 9 pi halves would be undefined. The cosecant of 9 pi halves would also be 1. The secant would be undefined, and the cotangent would be 0. Negative 5 pi fourths, again, kind of figuring out where you are. You could add 2 pi to this, or you could go backwards. This would be negative pi, so negative 5 pi fourths would be right here. So that would be negative square root of 2 over 2, square root of 2 over 2. So if you have the points, you should be able to do all of these, right? I'm going to just do 3 of these, and then you can do the other ones. But like the sine of negative 5 pi fourths is going to be negative square root of 2 over 2. The cosine of negative 5 pi fourths is negative square root of 2 over 2. And the tangent of negative 5 pi fourths is negative 1. I will remind you that when you do the reciprocal of this, when you do the cosecant of negative 5 pi fourths, remember that this is one that if you just flip it over, I want you to rationalize that, because you would get negative 2 square root of 2 over 2, or negative square root of 2 is what you should have there. Okay, the cosine of 0, or 0 is right here. 0 is what, 1, 0. So it's going to be very similar to A, but we're just going to switch our 1s and 0s, right? So if we change these to 0s, look at me taking the shortcut. The sine is now 0, the cosine is 1, the tangent is 0, the cosecant is undefined, the secant is 1, and the cotangent is undefined. 11 pi 6 is down here, and it's square root of 3 over 2, 1/2. And you would get all these numbers. Yes? Oh my gosh, I'm already at 15 minutes. How many more do I have? Okay, not too many. So sine is 1/2 on this one. Cosine is square root of 3 over 2, because it's just x and y. Tangent of 11 pi 6 is y over x, so that's 1 over square root of 3. So that makes cotangent square root of 3 over 1. That makes cosecant 2, and secant 2 over square root of 3. Okay? 29 is more like what you're going to see on the test. Not asking you to list out everything, but just asking you one thing. And this is knowing your unit circle, right? And so I'm just going to kind of draw as I need to. So cosine of 225, cosine is down here. So that is negative square root of 2 over 2. Tangent of 150, 150 is up here. And that's negative square root of 3 over 2, 1/2. So tangent is y over x. So that's negative 1 over the square root of 3. Sine of negative pi 6, that's down here. So that's square root of 3 over 2, negative 1/2. So the answer to that is just negative 1/2. Secant of 4 pi thirds. Secant, okay, hold on. 4 pi thirds is down here. So that's negative 1/2 negative square root of 3 over 2. And secant is with cosine, so that's negative 2 over the square root of 3. 7 pi fourths, cotangent of that is negative 1. And cosecant of 300, 300 is down here, so that would be positive 1/2 negative square root of 3 over 2. And cosecant is a reciprocal of sine, so that would also be negative 2 over the square root of 3. Those are exact answers. You got to know how to do that. Okay? 30 and 31, not going to be on tomorrow's part of the test, but definitely going to be on Wednesday's part of the test. This is where you have to use your calculator. So this one says if sine is negative and secant is positive, so this one's telling you that there's only one place. What quadrant is sine negative but secant is positive is in quadrant 4. So if you do this on your calculator and you do inverse sine of negative 0.7604, your calculator says negative 49.5 degrees, which is in quadrant 4, but it's not between 0 and 360, so you should add 360 to that. And the answer here that I would want would be 310.5 degrees. Only one answer because of this extra part that they said. If they didn't say this, like on the quiz number 2, you would give me 2 answers. So number 30, I'm in degree mode. Number 31, I'm in radian mode. And I'm going to do inverse tangent of 2.7381. And my calculator tells me 1.234. They want to give 4 decimals here. 1, 2, 3, 4. This is like what we saw in our quiz. So where's tangent positive? Tangent is positive here and here. So 1.2206, that is my answer in quadrant 1. I know there's another answer here that has that same angle. So to my second answer, I'm going to take pi plus that 1.2206. And my second answer is 4.3622. Draw the picture, okay? Okay. Story problems. When the top of the Eiffel Tower is viewed at a distance of 200 feet from the base, so here's the Eiffel Tower, 200 feet from the base, the angle of elevation is 79.2 degrees. Estimate the height of the tower. Label the picture. Elevation comes from the bottom up. So I'm going to do tangent of 79.2 degrees equals h over 200. So to solve for h in degree mode, I'm going to take 200 times the tangent of 79.2 degrees, and I get 1,048.4 feet. And number 67 says a ladder 16 feet long leans against the side of a building. So here's my ladder, and the angle between the ladder and the building, so between the ladder and the building, that would be this angle, right, is 25 degrees. Approximate the distance from the bottom of the ladder to the building. So this is the distance I'm looking for. So this one I'm not using and hypotenuse, so I'm going to do sine of 25 degrees equals d over 16. So again, I'm going to take the sine of 25 times 16, and I get 6.76 feet. That's on Wednesday's part of the test. And then the last thing I need you to look over is your polar coordinates. And so, again, you're going to have one just like number 2 here where you have to figure out your options. And so if I keep r the same, I can add or subtract 2 pi. So in terms of halves, 2 pi would be 4 pi. So negative pi halves plus 4 pi is 3 pi halves. So 3 pi halves is not an answer. And if I subtract 4 pi, that would be what, negative 5 pi halves? So if 4 stays the same, negative 5 pi halves. If I add 4 again to this, that would be, if I add another 2 pi, would that be 7 pi halves? Right? Yeah. So be careful on that. If I keep r negative, that means I'm going to add or subtract multiples of pi. So if I change that to 2 pi, if I add 2 pi, that would be 1 pi half. If I subtract 2 pi, what would that be? Negative 3 pi halves? Do you agree with that? I think those are the answers. And then changing from rectangular to polar. X and this is Y, so you're going to find R. So for A, if X is 7 and Y is negative 7, that's going to be down here, like 7 square root of 3. And so you can say 7 squared plus 7 square root of 3 squared equals R. So that's 49 plus 49 times 3, which is 147, which is 196, which is 14, because it's a 30, 60, 90 triangle. So R is 14, and then to find theta, again, you can use your calculator, but you don't have to on this one, because if you did like the sine of this, the sine would be 7 square root of 3 over 14, or square root of 3 over 2. So I know in quadrant 4, the one that has a y value of square root of 3 over 2 is 11 pi 6. But you could use your calculator as well, unless it said to give an exact answer. And remember what we talked about on this one. Like, I know this is a 45, 45, 90 triangle. So when I look at B, I feel like my voice is just getting further and further away from the thing, but it's too late now. 5, 5. Phi 5 would be here. And so you can do Pythagorean theorem, and you would get that r is 5 square root of 2, and the angle would be 45 degrees or pi force. And then these are just very straightforward, but the equations, right? R cosine theta is x, so x equals 5. R sine of theta is y, so y equals -2. Tomorrow, you have to know how to convert from degrees to radians and radians to degrees. You have to know your unit circle, and you have to know